Great. So you're officially welcome to another session of our PLD discussion. And in today's session, we are looking at operations on singly linked lists. Our focus will be on two different operations, insertion and deletion. The reason why these are important is that when we talked about the advantages of singly linked lists, or even advantages of linked lists during our last session, which the video is currently available on YouTube, we mentioned the fact that if you want a fast insertion or fast deletion, then the data structure of choice here will be the singly linked list or will be linked list. All right. That means that linked list is a bit flexible when it comes to, it's more flexible when it comes to inserting and deleting. All right. For that matter, once we are learning linked lists, there is no way we can ignore these things. We have to see how we do insert a node into a linked list and how we do delete a node into a linked list. So these are the two operations. In fact, there are a lot of other operations that can possibly be done, even though they may not be the most efficient. For instance, you could be asked to do a search on. So the operation is searching for a particular element in a list, the same way you do search for elements in an array. That can be asked, or you may be faced with a problem like that you need to do. And in fact, I think even with searching, we don't have a problem, because to be able to delete and insert at certain points in time, you do some form of searching. So that's not a big deal. But we have others like reversal of the linked list and a lot of other things that we can have. We can even be asked to go and make updates to the list, okay, or a node in the list. So all those operations comes in, but the basis is knowing how to insert and how to delete nodes from the list. Once we go through this, hopefully every other operation that you are going to do on linked lists, you should have the basic knowledge or understanding to be able to pull it through. Okay, so we are going to focus on insertion and deletion. The next important thing that you need to take note of is the fact that anytime you mention an operation in a linked list, you have to ask yourself, at what point in the list are we doing this operation? Okay, very important. At what point in the list are we doing this operation? So the first thing that we can do is we can do it at the beginning, okay, or the starting or start of the linked list. We can also look at the end. So these two are the common ones, the start and the end, and it's quite easy to work with. In fact, that is what makes working with insertion and deletion or these operations easy when it comes to linked list. It's easy to add to the start to the end. Then finally, we can be given a specific position to insert the link, to insert the load, or we can be given a specific element in the node, okay, or a specific node that, so let me say specific node after which or before which we should insert or delete. I hope you get it. We can be asked to, let me just focus on insertion, just using insertion in explaining this. We can be asked to insert a new node at the beginning of an existing list. So last time during the intro to singly linked lists, I mentioned using Instagram as an example, where all the new images will find themselves at the top when you post your images on Instagram or media on Instagram. Any new media that will come will be on top of the other. That means that you are inserting at the beginning. So we can be asked to insert at the beginning. There can be some other apps that when you insert, it goes to the bottom. That's also possible. Okay, that the first ones will be at the top. In fact, in our normal WhatsApp chat, yes, WhatsApp chat, when you put your message there, it comes to the bottom. Okay, so the most current is at the bottom. That means we are inserting at the bottom. All right, that should make sense. But then we could be asked to also insert at any given position, assuming you missed something. Maybe somebody sent a WhatsApp message, okay? This message was sent earlier, but there was no internet access at that point in time. So the message didn't load. And the recipient has sent you some messages. I hope you are getting the concept that I sent a message at 6 a.m. this morning, okay, to you on WhatsApp. Unfortunately, I was offline, so you didn't receive the message. Then you came to send me a message at 7 a.m. 7 a.m. was when you came to send me a message. Then I received it. Okay, let's say you sent it. I came online. So this is me. This is you. I came online at 7:15. When I came online, my message has to be sent to you. Okay, so there could be an operation where instead of letting my message come after yours, we want to insert it before yours so that you are aware that I actually sent this message before you. That is not the regular operation that happens in WhatsApp, okay? But it's a perfect example that I can give here. The focus is that with a list, you can be asked to insert at any point in the list. The most efficient is inserting at the beginning or the end. That's like the easiest. However, you may also be asked to insert at any point in the list. So we have to pay attention to that. So there is deletion as well, and that can also be done for each of them. So we are going to look at how do we insert at the beginning, how do we insert at the end, how do we insert at a given position or with a specific node, how do we insert after or before. So depending on the problem that you have at hand, you may decide on which of these to go with. All right, now let's take a practical example. Goodness, I have to mute you. There is some noise coming from your end. So you can unmute yourself. I mean, you can mute yourself as well. Anyway, let's take a look at it. Let me draw out a linked list with 3 elements. From our last discussion, we actually learned how to create a list and how to go through and find the members of the list, that is, traverse the list. Okay, I'm drawing a list with 3 members here. Then we are starting with insertion. Let me title this. So our interest is in how to insert. We always have a head pointer here that points to the start. I hope we haven't forgotten that. Then another important thing is that this over here points to now, okay, or the address portion of this is now. This is, say, node A, node B, node C. In the example that we used during our first session on linked list, we were putting ages here. So let me go ahead and put some age here, say 49, 35, and 14. Then this will contain address of B. Okay, over here, the address here will be address of B. That means that this will be linked to this node. This will contain address of C. So it will also be linked to this node. You and I know that anytime you create a node, and we discussed how you create a node last time, we used malloc to help us create, allocate space for the node, and we now fill that space with the given values, including the address of the adjacent node. All right, so once a node is actually, we are looking at malloc creating some, leaving or storing some space or allocating some space in memory for us. There should be an address to that memory, okay? And addresses, for as we know by now, are indicated indicated by hexadecimal values. However, to simplify things, we can write the addresses in a way that we can appreciate. So let's assume that this is 450. Let's say this is 320 and this is 750. I intentionally wrote them in this way just to draw your attention to the fact that they are not in contiguous memory locations. B, when you go to the memory, B will not necessarily, is that my network? Can you hear me?
Yes, we can hear you.
Hi. Okay. All right, sure. So what I was making reference to is I intentionally wrote this 450, 320, 750, assuming that these are hexadecimal values representing the location in memory. I intentionally wrote them as such to indicate that they are not in continuous memory locations. So instead of me writing say 450, then here I write say 470, 490. They are not. We can't predict it. They can be. It can be that they are. It depends on the space that is available at any point in time when they are being executed, okay, or when they are being created. So it could be anywhere inside the memory. That's why I'm representing them as such. This means that over here we'll have the address 320 stored. So here you just picture it as room numbers. Okay, so A has the room number of B. B has the room number of C. That's 750. That's the address of C. And C has 0 or now. Okay, then this is our head. Always what we'll have access to is just the head. And the head will just give us, how is it called? The head will give us address of the very first element. Okay, so this head contains 450. That means it directs us where this is. So when you look inside the memory, let's say this is your RAM. Okay, let's say this is your RAM. Let's say this is your RAM and assume that we have it as a grade. We could have it such that the address 320 is here, address 450 is here, then 750 is here. So this is where you're actually storing node A, and you're storing, oh sorry, this is node B. You're storing node A here, and you're storing node C here. Yes, so this is how the linked list can be represented in there. But what makes it a linked list and why it's important is that we would have A containing, so inside here, since A will also contain the address, there will be a space. So this is just the location. Maybe I should have written them outside to make them easy. Let me delete this. Okay. Then this is C. All right. So with B contains the 835. A contains the 849. Then C contains the 840. But we are looking at their locations. This is located in memory 320. This is 450. And this is 750. Okay. So what is happening is that in here, the node B itself, it doesn't just contain 35, the 8. It also contains the address of the adjacent one. And you see that it is pointing to C. So it contains C's address. So in here, it contains 750. That means that B knows that I am connected to this guy down here. Even though it is not close to me, I know very well that I'm connected to him. Then A also contains the 849, but as part of its value in here, it has the address of B, and address of B here is 320. So A, even though it is on its own, knows that I am connected to this guy over here. And because there is only one link each, A to B, B to C, that makes it singly linked list. If it was a double linked list, we will have a backwards connection sort of. But for now, we have only a forward connection, just one connection. C is not connected to anything. So it doesn't contain the address of anything. In fact, the address value here is 0. That means I am not connected to any other person. So that is how it is represented in memory, just for you to realize that it is not in contiguous memory locations, unlike that of arrays. Arrays are the ones that are represented in continuous memory location. So usually when we write it this way, and you don't visualize it well, you would think that, oh, in memory, this is how they are presented. No. So what is important here is to remember the address that head points to. So last time I made mention of the fact that usually when you are working with a linked list, okay, you may not be preview to the fact that a node called A exists, or a node called B exists, or a node called C exists. No. You just have an idea of what's the structure that was used to create, the template of the structure that was used to create it. How does it look like? You have that provided for you. Then the next thing you have is the head. And that is all that you need. You can do every other operation once you have those ones. Because with the head, you can open the first node. Like you can have access to the first node. Once you have access to the first node also gives you the address of the second node. So you can then go to the second node. The second node also gives you address of the third node. So you can go to the third node. By reaching the third node, you ask it for an address and it says, I have none. So this is the end. That is how it is represented in memory, and that is what it means. So now let's look at how do we insert an element at the beginning. Okay, so insert an element at the start of the list. How are we going to do that? Once you are going to insert an element, it means that in the first place, we need to have that element. So we will need to create a node, right? Or a node will have to be given if you are going to insert it. And remember that a node is basically just a structure that contains a number of values, okay, or not values per se, I mean a collection of data. It could be any form of data. So it's just a struct. Remember that. It could be anything. Like last, when I was using Instagram as an example, I mentioned that if you are using Instagram, this node could bear the URL to the image, the meta description of the image. It could have the caption that was given to the image and any other relevant thing, who posted it. We could have the username attached and all those things. But once we put all of these things together as one, we are referring to them as a node. Okay, so if I tell you that I have a list, but I need you to insert a node at the beginning of the list, then you should remember that that node needs to exist. The node that I'm going to insert. So if it does not exist, I have to create it. Okay, how do you create node? Using a pointer to the struct that created the node. So in the example that we use, which we are going to continue using, we said struct node. Then we define the structure as int age. Okay, then the address are struct node pointer to next. Okay, I mean pointer next, so pointing to the struct node. This is the structure that we are using. Once we are using this structure and we are going to create a new node, how do we create it? We first declare, please. These things, we have done them already, so I don't have to spend a lot of time here. If you don't remember, or you weren't here, or you are yet to watch that lesson, the lesson is already available on YouTube, so you can check it out. But to create the node, I need to first declare it, say struct node, then give it a name, the pointer name, which is a new node. Right. Now, this is just a declaration that, oh, I am setting new node as a pointer to a given node of this nature. Okay. Then the next thing I'll do is to allocate memory space for it. So I can say that new node is equal to malloc. Then I'll pass the size of this structure here to it. So size of structs node. But before then, you need to also typecast the outcome of malloc to extract node pointer. Please, if you don't understand all this, you have to go back to the previous video. Once we have created this, we have to check if malloc didn't return now. After checking that, you now go ahead and pass the value to this. So new node, let's say the age is equal to, our age here will be, say, 59. Remember, this is the list we are working with, 49, 35, 14. We want to insert a new node here, and that's the node that we are creating here. So we are creating this node, and the value here is 59. So now we have a node called new node. We need to go and insert it into this previous node. The question is, we are going to insert it in the front. That means it has to come before node A. So how do we have to do that? And it is simple. Here there is a connection between head and the first one. So if we want to put a specific node in between them, then the only thing that we have to do is to make sure that this new node that we are bringing, let's call this node AA. Node AA, we have to now redirect head to point to node AA and direct node AA to point to head. That means that we can then get rid of this connection. Okay. And basically, this will mean that we have added a new node to our list. So our list is now 4 members, starting with node points, starting with head points to the first one, which is AA, then AA points to A points to B points to C, and C points to now. That's basically how we are going to add it. But let's see the algorithm. How do you actually achieve this? We now know that for us to add a node at the beginning, first we create the node if it doesn't exist. Let's create it. We've created a node. Once the node is ready to be inserted at the beginning, the concept is that we just need to redirect head. Head should point to the new node, and the new node should point to what head was originally pointing to. But how? Systematically, how do we do that? Are you going to point head first, or are you going to point this node first? That is where the trick is. Let's see. Now, please put on your reasoning caps. Let's do some reasoning here. Or maybe I should draw it separately. Let me just zoom into it. So we have just head. Okay, this is my head. And head is pointing to the first node, node A. Okay. Let's just hot it here. We need to insert something before them. We have created node AA, and I want to insert node AA before this, before node A. How do I achieve that? That's the question. And systematically, how do we do that? For now, we are aware that to achieve that, you need to connect head to this and connect this to this. But the question is, which one should come first? So let's try this one first. Let's delete head. So we'll get rid of this connection, okay? And repoint head to this node. That is possible by writing your code saying that, oh, head is now equal to our new node that we created. That is what we have done here. But after you have done this, the question is, how do you point this to this? And that's going to be a problem. Reason being that initially head was containing the pointer to this, so we knew the address of node A. But now you have changed the value of head, so we no longer have the address of A. Therefore, we can't point this to A because we don't know the address of A. Once you sever the connection, like you've cut this connection away, we've lost it. So at any point in time, if you want to do anything, cutting the connection of head is a big deal. And in this particular example, this means that we have to maintain the connection of head first, like it should be there. until we are sure that we want to move it, because we don't want to lose it. So that means that we won't do something like this. Eventually, we would link it, but that shouldn't be the first thing that we do. We still need to maintain our link to the first node. It has to be there, very important. Then let's now, since we know, once head is here, we know the address of this, okay? And when we go back to the values that we were using, this was position, address 450. So head was pointing to 450, okay? Location is 450. Head knows that I'm pointing to 450. So we keep it in mind. Once we know that, now let's just point this to what head was originally pointing to. So that's the first thing. How do you write this? This is called new node, as we know from what we created. This is called new node. So to do this kind of connection, all we have to write is say new node is equal to head. Don't be confused. Head is a pointer to node A. Head in itself is not a node. So you can't say that when I write new node is equal to head, it means that I'm pointing to head. No, I'm not pointing to head. Head is a pointer to this first node. So the address 450 is not the location of head. It is what head is pointing to. So as soon as I do new node is equal to head, all that I've said in this specific example is that now I've said that, sorry, it should be new node next. It should be the next here, the address value here. Okay, sorry about that. So it should be new node next. So the next of new node should point to head. That's what I'm trying to do here. So this space, all that I'm doing here is that this space should now be 450. So that it is pointing directly to this. Okay, the value here is 49. It's pointing to node A. Now that I have this connection, I can go ahead and delete this other connection. Okay, because my head can now be pointed to this. How do we do that? Just as we did it earlier, we just say head is now equal to our new node. Remember that new node itself has its own address. Say let's say 810 is the address of new node. So we are now changing the value of 450 to 810. That is how we insert a node at the beginning. Let me go over this again. If you have any questions, you can ask me at this point. We have head, which is a pointer, pointing to our first node in our linked list. And the first node in the linked list is called A, node A. And node A can be found in memory location 450. It's just a representation. Okay. That means that anytime you call head is actually containing 450. Like it has this value in memory. The address that it is keeping, it's a pointer to it, so it's pointing to this address. If I want to now introduce a new node that we have called new node, so let me use that name, new node. If I want to introduce it, pay attention. We need to do the right connection first before the left connection of the new node. Never forget that. You need to do the right connection first before the left connection. I explained that if you go ahead and sever this connection by doing the left connection first, okay? If you do the left connection first, the problem is that after you have done this connection, now you have changed this 450 to what this is, and we said it's memory location 810. So you have changed this to 810. So only head knows only 810. It has no idea what 450 is. And you and I do not even know about 450 because we have severed that thing. Like we have no idea. Because we are not going to be printing out the addresses to keep it in mind that, oh, before I did my connection, head was containing 450. So now I know that I just have to point this to 450. No, we are not privy to that information because we are not printing the addresses out. In fact, we never want to work with addresses. That is why we created pointers. If we ever wanted to work with addresses, there will be no need for pointers. We'll just go and copy the memory location and use it. But we are using a pointer. And now the pointer that will point us in that direction, you have killed it. You have now used it to go somewhere. It's like someone who is going to show you the road to a place. And before you got there, they've moved the person to a different junction to be directing another set of people. So head was ideally supposed to be pointing us in this direction. We've now moved it to here. So head only knows this new node. How then do we get the address of this one? We've lost it. In fact, we've lost the rest of the list. So if there are 1,000 elements in that list, we've lost each of them. So we never want to do that. Always, we want to do the right connection before the left connection. And what I mean by the right connection is that maintain the head connection to the first node, then introduce a connection between the new node and the first node. Okay, so this should be there. That means that this is not 810, it's 450 that we know. Then, once you already know the head is pointing to 450, this address part of the new node is having the age 59. This has the age 49. The address part of the new node, once you are aware that head is here, just go ahead and say, okay, new node. Remember that I'm using nest because we defined it in the structure we are using. We said that the address is being kept in a pointer called nest. That is why I have the liberty of using new node points to nest. Then I'll assign it to head. Then I say that don't mistaken this. When I say it's equal to head, I'm not pointing this to head because head is in itself not a node. Head is just a pointer to node. So what I'm actually doing is that I am pointing to where head was originally pointing to, okay? So there's no connection like this. This thing is not easy to delete. There's no connection like that. So by doing this, new node nest is equal to head, what I'm actually doing is that I'm pointing to this node. Now there is a connection between our new node and this. So the address here is 450. We've stored the address of this new node. We can then go ahead and redirect head here. That means this will no longer be. Well, how do we redirect it? We know head. Let's point it to the address of our new node. New node in itself is a pointer. Don't forget that all that we are working with, we are only using pointers. This new node is a pointer. Okay, if you ever forget, remember that malloc returns a pointer. So new node is a pointer. Okay, so any node you are working with by itself is a pointer. So if I say head is equal to new node, all that I'm saying is that head should now take the address of this node that I've created, and that address is 810. So head now points to 810. It no longer points to this. So if I'm traversing this, I'll start from head. Where do you point to? It points to node A, new node. New node, where do you point to? I point to A. A, where do you point to B? B, where do you point to C? Then we end the list. I hope that is clear. So basically, these are the 2 lines of code that we need to implement the insertion at the beginning. Obviously, we'll write other lines of code. But once you know how to create a code, a linked list, once you know how to traverse a linked list, this is just the 2 lines of code that you need to know to insert a new element at the beginning or a new node at the beginning of the list. Should I go to code or I should continue this before I go and write the code? What do you suggest? We jump to go and write the code, or I should finish the insertion, then we'll go and write the code for insertion. Yes, suggestions from you.
Conclude the theory and then we'll do the code.
Okay, then let's go on. But please remember what we have done here. Here to insert at the beginning, I've mentioned importantly that always do the right connection before you do the left connection. In fact, it applies to the rest. We are still dealing with insertion. Remember, this is insertion. When you are going to insert a node, always do the right connection first before you do the left connection. Okay, so now let's look at inserting at the end. insert at end. The node or the list that we are dealing with has 3 nodes originally. Okay, it has 3 nodes originally. That's A, B, C. C is the node at the end. So for us to insert a node at the end, obviously we need to create the node. So you should go back to your lesson on how to create a node. So assuming that we have created a node, we have allocated space to it. I think I even recap it here, so shouldn't be a problem. Yeah. So you do your declaration, then you use malloc to allocate space, then you pass the values to it. Okay. That's how you create a node. So let's assume here that we have already created a node. This is node A, node B, node C. Now we've created a node called new node. New node. Remember that node C points to what? Now. Okay, that's all. Node C points to now. So our interest now is to get node C to point to new node. That's our interest. Get node C to point to new node. And I've said that when you are doing insertion, the first thing you do is what? Do the right connection before you do the left connection. So the new node here that's the next part, which bears the address. What are we going to point it to? If we are going to insert it at the end, that means that after inserting this node, it becomes the last node or the end node. And we all know by now that the end node always points towards now. So that's the first thing we have to do. We have to point that end node to now. So we'll go ahead and write a code as new node next. New node next is equal to now. That means we've done the connection for this. Okay, then we need to come and connect this node to this. But how do we do that? Remember that I said when you're working with linked lists, the only thing you have is this head. You don't have any other thing. But with the help of head, you can traverse. You can go through each of them and land at any of the members that you want. So in our case, we have to create a temporal pointer that we are going to move. Mind you, we could have moved head, but you are forbidden to move head unless if you are reversing the link, which we are not doing. Okay, so in our basic operations with linked lists, remember that you are forbidden to move head. I said there are exceptions, but at least for the basic ones that we are going to be doing, you are forbidden to move head. So always just know that head points to the first, so you shouldn't move it. Now I want to come here. So what do? I create a pointer. Say I call this pointer temp. Okay, and this pointer of type struct node will take what head was pointing to. So initially it will point to A. In fact, we can even call it a node because we will pass values. We can pass values to it. Okay, so we let it point to this. Then we will now move it. So we change it because we want to carry along. Okay, so we are going to use a loop to loop through it for as long as the next value is not now. So we are checking. When we come, we point it to A, then we check A. Is your next value now? If not, then let's point this. Let's point it to B rather. Then we'll find out B. Is your next value now? If not, let's move this to C. Point it to C. Is your next value now? Yes. So now we have gotten C. Like we've gotten this node. We're looking for it. To get the end node, our interest is get the node that has its next pointing to now. Hope it makes sense. To get the last node, we all know by now that the last node has its next or address value pointing to now, or address being 0. So we just created a temporal node and we are using it to traverse the list. So all that this temporal node is going to do is starting from the first node, we are going to check. Kindly give me a second, my brother is calling. Hi everyone. Please, if you have any questions, go ahead and ask me. I need to send something to my brother right now, so quickly let me do that. But if you have any questions, as I'm doing that, just go ahead and ask your question, then I'll answer. Any question?
Hello, doctor. Please, I have a question. The struct node next, what is it? Is it? I need the pointer. But
Yeah.
what is the role of the struct node? This next struct node, is it like it links the different nodes together?
Yes. So it is what connects, helps you connect. Without it, we don't know any other thing. So for A, we have created a pointer, but that pointer, we are going to store the address of B in it. Okay, so this will be like address of B. And here we'll store address of C. Okay, so it is that next struct that helps us. When we were learning about struct itself, we didn't talk about like another struct inside it or a pointer to another struct as a member of one of them. Okay, but with the help of this particular one, it serves as a pointer. So you will pass the value to it. Once I've decided that the address of B is being stored here, okay, then it means that I now have a pointer to what I'm standing by. Do you get it? It's like we are standing in a queue, and for everyone, for each of us, the person in front of you will write their name and put it in your pocket. That's how it is, so that anyone that you pick, you know that, oh, okay, this is the person in front of me. Oh, okay, this is the person in front of me. So anytime you enter any of these nodes, each node is actually a struct. And that means that a struct can contain a lot of things. But as part of all the things the struct will contain, it has to contain address of the next one. That's why, to make it simple, we call it struct node next. Like we declare it and call it as next, so that when you are using it, it makes sense that, oh, okay, this, when I write something like new node next, all that it means is that this part of new node, where does it point to? Okay, if I say node A next, that means that node A, the next, this part of it, where does it point to? Does that make sense?
Thank you.
You're welcome. Okay, sorry for the delay. Let's continue. Yes. So this thing that we are doing is actually not new. From our last session to I walked you through how we traverse the list. So basically that's what we are doing with the help of temp. So as soon as we are able to locate the end node, once we locate the end node with a loop, now temp is actually the end node. Okay, when we are starting, we'll start by pointing temp to what head is pointing to. So when you declare your temp, you say temp is equal to head. That's the first part. When you declare your temp is equal to head. This means that temp points to where head is pointing to, and that's the first node. Then we'll now go and write a loop, say a while loop. Okay, but what are we checking for? We are checking if the next of temp is what? Now. So we are going to do while temp next is not equal to now, do something. Okay, so while temp is, let me write it here. So what we are trying to achieve now, this is traversing. Please, if you don't know anything about linked list, I beg you to at least know how to traverse it, because otherwise almost all the questions that you get will be a bit problematic for you. How to move with along the list, that is traversing it. So here we have created, obviously you would have to declare it with struct node pointer temp. Then you assign it to head. This is telling you that temp is now pointing to where head is pointing to. Okay, once you have achieved that, you are now going to use a while loop to check temp next. So let me draw the list here. So this is head to node A, node B, node C. Okay, so this A, B, C. Head was originally pointing to what? A. And now we've created temp. In fact, you can call it anything. Some people prefer to call it current node, so that you use it anywhere you know that, okay, this is where I am currently standing. Okay, but calling it anything you want, provided you appreciate what it means. So temp is now pointing to A. Okay, so in a while loop, I want to check, is this next thing here, is it now? Because if it is now, it means I'm at the end of the list. And that's what I'm looking for. I just want to get to the end of the list. So I'm checking if this is now. Okay, so how do I do that? I just say temp, because temp is pointing to this node. Next. That means I'm referring specifically to here. What is inside here? If temp next or while temp next is not equal to now, I want you to do something. So that means that here it is not now, so do something. Here it is not now, do something. Here it is now, stop. The while loop will break when we get to the last, because this is now. This is not now. Okay, so what do we do inside here? Once we find that this is not now, we are interested in the value here. Remember, the value here is just the location of B. So I could write this as address of B. So what we are checking here is the address of B now? Once the address of B is not now, it means that B is actually a node. So what will I do? Let me move temp and now pass it to B. So I'll simply write my temp is now equal to, how do I get B? B is, the address of B is what? Temp next. So I say temp next. And that's where people get confused. Remember that initially temp was pointing to A. So temp next was pointing to B. That is the difference. Here, when we started, temp was pointing towards node A. But temp next was pointing towards node B. So if I check that temp next is not now, that means there is actually a node there. I come and update temp and I say, okay, temp, you should now be equal to the temp next. So our temp after this first line, our temp now is equal to B. Then we'll come back to our while loop and check. Is temp next right now? Once temp is equal to B, temp next right now is equal to what? C. So we are now coming again to check, is temp next now? No, it's not now. So this is like, if it is not now, then let's move temp. So temp will have to now take a new value. It will take the value of temp next. Temp next was pointing to C. So we'll now say temp is equal to C, which is temp next. Okay, temp is now C. So we are gotten it here. Temp is now C. Temp next is now. So when we come here and say temp next is not equal to now, this will fail, because now temp next is now. So we'll break out of this loop. That means that temp, as we have it right now, is equal to C. Temp is now C. That means we have the end node of our loop. Then we can go and use it for whatever we are going to use it for. So this is the traversing part. You need to appreciate how you move along the list. Okay, that is the traversing part, how you move along the list. And hopefully this makes it clearer. Once we have been able to traverse the list, then we have it here, C. Temp is what is now C, but we know that temp next is pointing to now. So all that we have to do is make temp next now point to this. So we'll go ahead and say temp next is now equal to new node. We are done. We started by what? Pointing this to now, and we needed to point this to this, just as we did for when we were doing at the beginning. It's just two connections that we need to create. First point the right one, then point the left one. That's what we needed to do. But here we didn't know which, when we were inserting at the beginning, we knew that it was the head. So we easily went ahead, pointed this, then we redirected head. But right now we don't know. So we have to go and find what the last node is. In fact, the same concept will apply to when we are looking for it in any position. Create a temporal one and traverse to the position you are looking for. Then you can do the connection. Any questions?
Sorry for drawing you back. I don't know
Okay.
if you can go back to the traversing again.
Okay.
I missed out something.
All right. So traversing the list, I said it's very important. So let me go over it for you. We have a linked list with 3 members. That's what we are using. Node A, node B, and node C, right? You need to remember this. And we want to identify node C. For now, we don't know exactly what it is, okay? This is our head. That's all we know. Remember that. Always, I say, you have no idea that there is A, there is B, there is C. If you knew them, you wouldn't do traversing. You just call C next. Like if you knew it, why would you need to traverse? So we don't know these ones, okay? All we know is the head. So what do? Head is pointing to the first node that I know. So I create a temporal node, call it temp, okay? Then I say temp is equal to head. What have I done here? All that I've done is that now temp is a pointer pointing to the first node. That's what I've done, okay? But once it's pointing to this node, it means that I have access to the value here. So I want to check, is this now? If it is now, it means I am at the end of the list. When we're doing the last thing, I said 2 main important things, the head and this now thing. The now means that we are at the end of the list. So if I want to get to the end, then that is what I should be looking for. Is this now? Okay, but how do we identify this? Since temp is now pointing to this node, it means that I am checking for temp next, because we have called each of these, like the second part, that's the address. We've called the address part next. Okay, so temp is pointing to A. So we are saying, is A next equal to now? But unfortunately, in our case, A next is not now because it contains the address of B. It is here. So we just create a while loop to check if this is not equal to now. If it is not equal to now, so once we have checked and it's not equal to now, what should we do? If it is not equal to now, I want you to now move temp to the new node. That is the next node. And it's simple. So temp is now equal to what this was pointing to. That's the next node, which is identified as temp next. Remember that when you are writing this temp, you haven't changed the temp yet. So temp next is still pointing to B. And now you are saying temp is equal to temp next. That means that your temp here is now B. As soon as you do this assignment, temp next has changed because temp is now B. So B next is not the same as this. B next points to C. So as soon as you said temp has moved to B, this is what you have done here. You have moved temp to B. It means when we come in here, we are checking temp next. It is no longer this because now this is temp. So temp next means that we are moving here. This is what we are looking for, address of C. And that is also not empty. So we come in here and say, oh, what you sent me to go and look for is not empty. So what do I do? Say, okay, then move temp to C. Say temp is equal to what that one was pointing for. So it's like, let me use this analogy. I'm sending you. I want to send you. There are a number of rooms. You don't know. The clue that I'm giving you is that I'm pointing you to the first room. And for each room that you go, there is an address of the second room or the next room. Let me say that. For each room that you go, there is an address of the next room. So when you go, just look. If there is no address, then that is the room that I want you to go to, because that's the end. If there is no address in that room, then that is where I want you to go to. But if there is an address, then move on to that address. So that's what is happening. Here, we are saying that this is the first room that temp is pointing to. So you went in here, then you use a while loop to check, because a while loop will keep you doing it. It's a loop. Will keep you doing the same thing. So you ask, check inside the room. Is there an address in this room? Then you found an address. Oh, okay, there's actually an address here. So now, instead of being in room 1, all that you are saying is that you have found the address of room 2. So you are giving the address of room 2. That's where you are going to. So now you move from room 1 to room 2. So your location now is in room 2. And you search room 2 and ask, is there an address in room 2? And you found another. So once you found another address, then it means that you have to change your position. You have to go to the next room. So you come here and say, okay, I am now going to the next room, and this is it. Then you come to the next room and you find that there is no address there. So this is where I am. So temp is now the room that you are looking for. I hope that makes sense. Basically, this simple thing here is helping us traverse it. That's all. And that means we can actually get the value of this. We can get a value of the last one, depending on what we want to do. But now we are just interested in getting it, looking at it, and redirecting where it points to. I hope it makes sense.
Yeah. Thanks.
Welcome. So after we have done that, it's just about the connection. Temp is now your last one, so you connect temp to the new node. Now let's look at the last bit, which is inserting a node after a given position. So insert after a given position. Insert after a given position. Start thinking through it. How are we going to insert after a given position? So let's still go back to our lists, which is this, and this. This is A, B, C, and this is head. Okay. Let's assume that I tell you I want you to insert a new node between B and C. That is, if I tell you insert the node after position 2, because it's 1, 2. So insert new node after position 2. Okay. Insert new node after position 2. How are you going to do that? Remember, this is not an array. If it was an array, we'll just use, by fact, even inserting a value in an array is not an easy thing. But if it was an array, we'll just use the index to get there. But this we don't know. In fact, you and I do not even know the list. We have no idea what A is. Like these are not in existence to us. All that we are given is head. We are given head, and we are told to insert a new node after position 2. So remember, we would have to go and create a new node because the node that we are going to insert, okay? So I'm going to talk about it. You know very well that you have to have that node. Unless if the question that you are dealing with or the problem set you are working with, the node is already available. But if it is not available, then you have to create it. And we've talked about how to create it. The most important thing is how do you traverse it to get here? You want to insert it after this, after the second one. So it means that you have to get to the second one. Okay, so let's assume that this is the new node that I've created. Okay, called new node. Don't forget that earlier on I said when you are doing the connection, you always want to connect the right. So we are going to connect the right to this. Then we'll connect this to that and get rid of this. Okay. But any of these will only be possible if we know what this node is. For as long as we know what this node is, we will know C because this contains address of C. So we'll just pass the value here to what this contains. Then we'll pass this node its the address to the address of this. Hope it makes sense. So now let's find how do we get to this position. We create a temporal one, a temporal node, which by now you should know how to create it. Struct node pointer temp. You have created it. Then the first thing you want to do is assign it to head. Always, because we start traversing from the head, because that is the only thing that we know. So now you know that temp is pointing to head. You are going to do a loop to check something. But how are you going to check it? This time around, we are not checking if it is now because our goal is not to get to the end. Our goal is to get to a certain position, position 2. That means that we can use a for loop for this since we know the end. We can use a for loop. Maybe initialize an integer called I to 1. Okay, because we are going to start from 1. So initialize an integer called I to 1. Say I is equal to 1. Then we check the condition. Is I less than position? If it is less than position, then we are going to do something. Afterwards, we are going to increase I. Okay. So this means that before we enter this loop, because we are going to operate on temp inside this loop, but before we enter this loop, we know very well that this loop is pointing to the first node. Okay. So if we check I is equal to 1, okay, we are using 1 because we know that, we are starting from the first node. So I is equal to 1. And we are looking for position 2. That means that I, which is 1, is less than 2. 1 is less than 2. So in here, what do we do? Once this is not the node that we are looking for, okay? Because the position that we've been given, that's what we are using to guide us. And we are at 1. So we haven't gotten to 2 yet. If it is not it, let's now update temp. We have to give a new value to temp. But temp was originally pointing to A. Therefore, temp next was pointing to B. So we can say temp is equal to temp next. Please, you see this thing is repeating itself. It's not different from what we have been we did earlier. Temp was originally pointing to this, but there is a next column here. And this next column gives you the value of B, the address of B. So you know that, I can access address of B with temp next. So once I have not gotten to the position that I want, then let me take this away and now move temp to the next one. So temp is now pointing at B. And we increase I. So I has become 2. So when we get here, we check is 2 less than the position. So position will be given as an integer sort of, okay? Is 2 less than the position? 2 less than 2, no. So we are done with this loop, meaning now the term that we have is actually this one. Let me use a 4-member linked list to illustrate this. We have A, B. You realize that the headache has been around the traversing. So that's why I keep saying that it's very important for you to know how to traverse the list. Because almost every operation that you are going to do, you may end up having to traverse the list. Okay. We all know that with this sort of representation, there is what? Nest, nest, nest. And these nests are pointers to the adjacent one. This will point to now. Okay. This will point to now. So what do we have here? We start by, this is head. We know head points here. So we start by assigning temp to head. And what it basically means is that temp now points to where head was pointing to. So temp is pointing to node A. Okay. Then we have been asked to insert C after C, that's position 3. Okay, so our goal is we have an integer position and it's 3. So we are going to use a for loop. This time around, the for loop is best because we know the value. You can use a while loop, but I mean, for loop is simpler in this case. And we initialize, we are starting at node 1. So I like to initialize at 1. Somebody may decide to initialize at 0, I is equal to 0. Except that when you initialize at 0, then you should be looking at I should be less than position minus 1. Okay, if you are counting from 0. And it's not very comfortable like that. You may end up getting the wrong node. So what I'll do is always initialize with 1 in this specific case because I'm starting counting from 1. It's not an array. I'm starting to count from 1. So I is equal to 1 already because now I know this is already pointing here. Then I want to check if I is less than the position that I was given. Okay. In fact, okay, let's go on. If I is less than the position that I was given, then we'll do something afterwards. We increase I. Okay. So what do we actually do in here? What we do in here, then we check first one, I is equal to 1. So the first, once it is equal to 1 and is less than the position we are looking for, let's update this. We want to move this to the next one. But how do we do that? This was temp initially. Okay, when we created it, it was pointing to this. So temp. But the next was pointing to B. So all that we have to do is now say temp is equal to what it was originally pointing to, which is temp next. Okay, so when we enter and we do this, I now has become 2. Then we'll come and check is 2 less than position, which is 3. Yes, 2 is less than 3. So we now say, okay, our temp should now be equal to what it was originally pointing to, which is this, the next one. So we are now at C. Temp is now C. Then we'll come. I is now 3. Is 3 less than 3? No. So we have broken out of this loop. Once we break out of this loop, we cut this. Temp is now on here. So we have the member at position 3. That means that now we can go ahead and put something here. How then do we put something here? The new node that we created, how do we put it there? We put it there by doing this. First, connecting this to here. But will you remember what this is? The address of this. The address of this currently, we know that temp is equal to node C. Remember that. After we came out of this loop, we are at node C. That means that temp next is what? Node D. Remember that. So if I want to point this new node next, the next of the new node to node D, all I have to do is new node next is equal to temp nests. Don't forget that, because we got here with temp. This is our temp, it's node C, but the nest of temp is pointing to node D. So if I want to now point this to node D, then I have to equate or assign temp nest to node new node next. Then afterwards, let me redirect new node temp nest to this rather. So I'll then come back and say temp nest is equal to new node, and that is all. I've inserted at that given position. So this is how we do the insertion of the at the various positions. That is at the start, at the end, and in the any position that we are given. Okay. The other thing that you can do that I'll leave as assignments when you go, you try and practice that one, is that instead of giving you a position, we could have given you a value. Okay, that insert it after where the age, in our example, we are using age for our value. So insert it where the age is actually equal to 29. That means that in this your loop, you will be checking for the value that is in each of them and see, is the value equal to 29? If it is not equal to 29, then let's keep going. Let's keep going. But you have to also be mindful. In fact, there are a number of checks that you have to put in place so that by the time you get to the now, if you have not gotten it, then you know that, oh, it doesn't exist. So for instance, if I gave you position 7 to insert something after position 7, whilst there are only 4 of them, okay, you can't just come and say I is equal to position 7. You run into an error because the position 7 doesn't even exist. Okay, so at the end of the day, you are going to end up pointing your temp to something that doesn't even exist. So what will you have to do? You will have to set some checks to check that we aren't in. So maybe after you enter here, you check if we are not in the now. If we are not in now, that is, if temp is not equal to now, then you do whatever you are going to do. So there can be a number of checks and balances put in place that is when you are implementing it by yourself. So let me quickly go to the code and let's try writing the code out. I hope once we are done with the insertion, doing the deletion wouldn't be challenging, because I wouldn't want us to come back again to the same topic. Cool. Okay. Any questions so far? I'm loading my virtual machine. So any questions?
Doc, can you use a if statement to do the insertion at the back?
To do the which one?
Insertion at the back at the end.
Like I really don't get it.
Can you use if statements rather than while to do the
Other than
insertion
while
at the
loop
end or at the beginning?
No, you know that when you write any of these loop, in fact, there is a condition in the loop. It's actually checking if something exists or does not exist. Okay, because if you just use if, your temp when you started, so let me go there. Something like this. When you started, your temp was pointing to head. So if you just use if temp is not equal to now, temp is actually not equal to now, and that's what it's going to do. Or if you check if temp is equal to now, like it's just once, okay? But our interest is to have it repeat. That is why we use the loop. So that's the difference. With a loop, it will repeat itself in checking if a condition is met. So in fact, the loop is like repeating the number of ifs. It's doing if, like if this, if that, if that. Hi.
Hi, Doctor. I think a simple answer to that question would be Yes,
Okay.
I think the simple answer to that question would be that while and for they are loop, and if it's not a loop statement, because it's just a conditional statement that check for something, like if something meets a particular condition or not. But a loop is to traverse over something like over and over and over again. That's why you can't use if in a condition like this.
Yes, thank you. I hope you understand.
Yeah. Thanks.
Well, I think, okay. So I wrote some code so that we would be fast with it. Okay. I don't know if let me just to do a quick recap because we are going to build on what we did the last time. So let me call a new folder. Then inside this folder, we are going to have new file main.c. Okay. Go back to what we created the last time. We created. Trying to recreate the last time. Okay, node.cs. That's what we created last time. So this actually here was what we did during the last session. And basically what we did there was to create a linked list. And that's what we are going to be playing with right now. All right, so those of you who are in here can go and check it out. The view is available. We created, then we even ended up traversing the list, okay? But for now, our interest is in just creating. So, in fact, let me mention something here. During the last one, this is what I did. I was checking while here, because our interest is in printing the values, okay? And I said during the last session, I mentioned that there are a number of ways that you can do it, but this is one of them. So we checked if the temp next was equal to null or not. Then eventually we had to. No, okay. I think I've. All right. Eventually we had to come and print one more outside, okay, because we're checking for the next. Maybe when we are doing it, you say it. But if I take this and I'm checking for the actual thing, then I can get rid of this printf statement. Okay, that's also possible. So this will help me directly print each of them. But we'll explain it later when we are doing it. So for now, I want to comment this out. Kindly give me a few. The call has even ended. All right, so let's work with what we have here. All these will be commented out. So what have we done? We have created, this code is just creating the linked list. There are 3 members. We have 67 as the first member. I mean node A, node B, node C. So what I'm telling you is that mostly you will not be privy to all of these, okay? So let's assume we've created it. We now need to create a function. And that function, let me delete this one. That function is going to insert at the beginning, okay? So insert at beginning. Let's create a new file in here. New file, insert, let's say begin.c. Insert begin.c. In order not to waste time, I wouldn't bother myself doing the things that we need. I mean these things. Okay, so let me also create, I'll need to create a header file to put our prototypes and the structure in it. The struct will be in the header file so that all the other files can have access to it. I don't need to create it again. Let's call this struct. I'm just calling it struct.h. We know that we can call it anything we want. Then it means I have to create a file called struct.h. Okay, go ahead, create a file, call this file struct.h. Then in there, we are going to be putting the structure. So for now, let's copy this into it. Into where is it? Struct.h. Okay. Then let me end the if statement. Good. So we are good to start now. We are now coming to create this function. The function is not going to return anything. So the return data type is void. Void. The name of the function is insert begin. Okay, then since here we are going to be using the main.c to pass values to it, let's go back to main.c. All of these things, when you are working on it, you have to think about it. So we are going to call inserting, let's say insert new node at beginning, new node at beginning. We know that for each node that we are going to create, we need the value of the node, and we also need to be aware of what the head is. So this function that we are going to call insert at begin, we have to pass the head to it. But the head, what is the head? We have already defined it here. Okay, head has already been defined. That is, it has been given a value. But since we are passing it to a function, since we are passing it to a function and we want to come and be able to effect the changes to head, any changes that we go and make elsewhere, we want to effect the changes to head. What do you think we should do instead of writing head alone? Because when we write head alone, we are just passing a copy of it to insert begin. As in today's function, we are just passing a copy of it. So it means that we have to pass it by reference and not by value. How do we pass a parameter by reference? Say we want to pass the age 78. That will be the age. So we need to use the address operator here. The address operator, when we use it, it means we are passing the actual value. We are not creating a copy of it. We are passing the actual value to it. And this will inform us on, sorry, this age 78. This will inform us on the function that we are going to write, the prototype for that function. Okay. So let me come here and say, we know that we'll be receiving something of this structure, struct node pointer, but we are receiving a pointer to it because we passed the address. So it will be star star then head. Very important. Star star and head. Head originally was a pointer to struct node, but now our goal is we are passing an address, so we have to make it a pointer to a pointer. Okay, so that we'll go and effect the change to head in memory. Okay, then we would also take in an integer called age. So this is what our function will look like. Now our goal is to insert the new node. If you are going to insert a new node, then it means we have to create the new node. That's the first thing we have to do. We have to create the new node for us to be able to insert it. We've been given this. We have knowledge of it that, okay, this is the value we are going to pass to the new node we are creating. And we've been given the head of the linked list. So this is essentially what I've been talking about. At the end of the day, you only have the head. Then the value that, or the values that you want to insert in. Okay, that's all that you have. So what do we have to do? We have to create our node, create a new node. We have to create a new node. After creating the new node, then we can point the next of the new node. So sorry. After creating a node, we can point the next of the new node. Remember, this is like the right connection to what head was pointing to. That will be one of the things we do. Then after doing that, we will now redirect head to point to new node. So redirect head to point to new node. So basically, that is all that you are going to do to insert the new node in the starting part or the beginning of the list. But you know that all of these are not going to be just straightforward. There are a few things, especially the checks and balances that you have to do. We have to make sure that this head that we are being given is actually the list actually exists and it's not an empty list. Okay, like we have to be aware, if it is an empty list, you know that we are going to just connect the the head to the new one. That's all. Very important. So we'll have to check all of that. But for now, let's create a new node. How do we create a new node? We declare the node and give it a name. So we'll call this new node, just as we used in our example. Then we have to use malloc to assign memory space for it. We've talked about this already. And we'll typecast the outcome of malloc or the return of malloc to struct node pointer. Okay, then malloc the size of struct node. Okay, so we have access to struct node because we've put it in struct.h and we are going to call it on every page, so we'll have access to it. Now, ideally, you are supposed to also go and check if new node here is equal to now, because malloc can fail, and anytime malloc fails, it returns now. So if it is now, we just want to return probably -1. Hey, sorry, we said it's a void function, so it means it doesn't return anything, just return. Okay, but we can also leave it out if we want. And once we have created this, we can now pass the values to it. So we can go ahead and say new node, which we have created, new node, the age of the new node is equal to this age that we've been given. Okay, this age here. Okay, so let me change something so that it doesn't confuse us. Let me just call this value is equal to value. So the age here is coming from the struct. When you look into the struct, we have age as a member variable in the struct, and we have access to it in our function. That's why we are able to use it here. Okay, so new node, the age is equal to this. Then what will be the value of its next? Its next should be a pointer to what it's going to point to. Okay, but as I said, we have to check if the list actually exists and is not an empty list. Because if it is an empty list, there is no, we are not going to point it to anything. Okay, so the first thing we want to do is check if head, so let me do this, if head is equal to now. That is what we are checking here with this. Let me put it here probably. Say we are checking for check if list is empty. You know list is empty when the head is equal to now. It means that this list has nothing in there. When head is equal to now, list has nothing in there. So that's what we are checking. Is this list empty? If head is equal to now, then what are we going to do? It means that there is no list already. So we just have to connect the next of new node to now. Then we'll now connect head to new node. That is if the list is already empty. So we'll go ahead and write new node next, the next of new node. This is what we are doing right now is if the list is empty, next is equal to then now. So if it is empty, we want its how do you call it? We want the next of the new node to point to now. Then, after we are done with this, we will now come and assign what the head to new node. Okay, so we'll probably come out here and say head is now equal to new node. That's the address of new node itself, or the position of new node itself, not new node next. So all that we have done here, let me quickly switch to the board and show you this part. All that we have done there right now is that when we went in, we checked and say the head doesn't point anywhere, it's now. Okay, once head is now, what do we want to do? Our new node that we have created called new node is this. So all we have done is that let's point this next part of new node to now. Then let's point head to this. That is what we have done. But that will not always be the case, because there are times that it is not now. So else, if it is not now, what should we do? That's what we are going to look at now. If it is not empty, if it is not an empty list, then what should we do? If it is not an empty list, it means that head is originally pointing to something, which was what we talked about first. So now we have to move, let our new node point to what head was originally pointing to. Okay, so that is where this comment will come in. That's where this comment will come in. We say if it is not now, then point the next of the new node to what head was pointing to. So basically, all that we'll write here is next of, new node next is equal to head. That means we are now pointing the next of the new node to what head was originally pointing to. We come here after we have pointed the next. We now have to point the. We have to now point head to new node. Okay, so basically that's what we are going to do here. Redirect head to point to new node. As simple as this. So in fact, we are done. The only new thing is the fact that we checked if the list was new. We could have left it out, and essentially all that we are going to do is just this connection. The right connection is new node next. You point it to what head was originally pointed to, then point head to new node. Okay, so just to prove what we are doing so that we see it, let's write a print statement here and say I successfully added a new node to the beginning of this list. Okay, so hopefully if everything works, we are going to add the H to it and print it out. Oh, then I shouldn't have deleted the print statement. Oh, no. In the main.c. In main.c, it means I don't have to delete the print because we want to print the list out for us to see. Okay, so let me go back and grab it. Let me copy from here. Okay, so main.c. All right. So at the end of the day, we are just going to print the members of the list. Remember here that the list that we originally created is 67, 47, 35. And what we are trying to do right now is insert 78 in front of this list. The list is what? 67, 47, 35. Okay, so first of all, to prove that, let me just make sure everything is working. So I've not called a function, I'm just printing out the list. Let's try that and see. So we'll compile. Oh, let me cd into new. Okay, good. Then let's compile gcc main.c and say call this okay, let's just call it main. Oh no, temp. Where did temp come in? I thought I deleted it. Oh, I deleted the declaration of temp to. So this has to come. Okay. It's important. It has to be there. So these ones we did them the last time. That's why I didn't really explain them much. But yeah, we now have main. So let's run main. And you see what main gives us? The list of 67, 47, 35. That's the list we are working with. Let me do something here. There's some small cleanup. Good. So what we are interested in right now is to add this. Where is it? This insert. We want to insert 78 before 67. So we should have 78 printing before 67. That's what we want to do. And that's what we have written this function for. And hopefully when everything works, you should also print out this statement for us. I successfully added a new node at the beginning. So let's go ahead and compile this. We'll need to call, okay, let me call all C files so that it will be easy. Okay. Oh no. Oh, why? Insert begin struct node from incompatible pointer type. Oh, line what? 23. Anyway, I think what I haven't done yet, which I should have done, is I haven't declared a prototype of this function. Probably that's the reason why it's giving us an error. I need to declare the prototype of this in the header file. Where is the header file? Okay. But was that the reason? Okay. So that was not even the reason. The reason is that when we're entering the inserts here, we have double pointers. Okay. So we can't just call head like that. It always has to be pointer head. This. Because we want to affect the original value that head is pointing to. So anywhere you see head, it should be pointer head. We have it anywhere there. Okay, good. All right. Hopefully the problem should be solved. Another one, main, implicit declaration of function. Oh, the function itself too, there is no. Oh, I thought I did. That's what I did. In words, insert begin. In main. Okay, so don't call, have we not? Let me copy this and go and replace what is in main. Oh, okay. Makes sense. All right, good. So now we are good to go. Let me clear the screen. Clear. Then run this. Hey, what else is the problem? What's it? Node. The first one is line 5 of this node originally defined here as struct node. Yes. Passing argument 1 of this from incompatible pointer type. Why is this incompatible pointer type? Oh, we've already defined it, so we don't need it here. Then what is it saying here? Hopefully everything should work now. Oh, live debugging isn't easy. Good, finally. Okay, so now let's run a program. See, I successfully added a new node to the beginning of this list. 78, 67, 47, 35. So we've been able to successfully do that. Let me do some cleaning up here just to make sure we go to the next line. Okay, they should have that in front. Then let's run this again. Good. So I successfully added a new node to the beginning of this list. 78, 67, 47, 35. Originally it was this. I hope it makes sense. So let's get into the code. Basically what we did, if this wasn't part, if we weren't checking for the empty one, all that we did was point the next of the new node to what head was pointing to, then redirect head to point to new node. That is all that we did. Okay, so the first thing is to create your node. After creating your node and doing all the checks, go ahead. Here we check if the list was empty, then point the next of the new node to what head was originally pointing to. So that was also done here. Okay, let's move on to insert at end. Hopefully the codes will be available on GitHub, so you get to see and practice with them. So let's create the new one. Insert end, and that's where we are going to traverse. So this time around we are going to create our own how is it called? We're going to create our own temporal pointer or node to use for traversing. Okay, so in here too, there are a number of checks that you have to be doing, but I won't be paying attention to the checks. Okay, let me just go straight to what we need to do, because still I need to check if the how do you call it, the list is not empty. Obviously you need to check that. Okay, and if it is empty, you know exactly what to do. But for now, this is insert end. Insert end. So we need the head, we need a value. We are going to create a new node. This is what we do to create it. Then we check if it is not an empty list. If it is an empty list, this will go on. If it is an empty list, we have already gotten to the end like this. Okay. No, sorry. So here we will not have the else statements like this, because if it is not an empty list, it means the head is pointing to something already. So all that we are going to check is if it is an empty list. We check if it is an empty list. Oh, something. I think I should have corrected. There is an error that I have spotted here, that if it is an empty list, well, this is going to happen. But this shouldn't be like the, okay, I think, okay. Since I brought this one out, okay, that's it. But for now, we can't really use this. Else, if this is equal to now, let me go through it. If head is equal to now, that is, it's an empty list. So if it's an empty list, we'll do this. New node will point to this, then we'll now redirect this. So this will now come in here. If it's an empty list, okay, that's what will happen. But if it is not an empty list, then we are going to do the regular thing that we discussed as part of the theory. That's what we are going to do if it is not an empty list. Okay, but Mostly when they are teaching the theory, usually they won't even include it. But you, when you are doing it, you have to include all those checks. All right. So now we are not focusing on this part. In fact, we can even decide to comment this out and focus on the fact that the list already exists, so that we would do that. Maybe when we are done, I can correct that, just for you to focus on the exact thing that you need to do for adding it to the last part. So now we have our new node created, okay, but we want to traverse to the end of the list. How do we do that? We can traverse to the end of the list with the help of a new pointer or a new node. So we're going to create a temporal node to use for traversing, okay? So let me delete this comment as well. In fact, I even feel I should delete this so that we have space for everything. Okay, now new node age is this. Let's traverse the lists. That's one thing, that traverse lists with a temporary pointer or node to temporary node to get the last node. That's what we want to get the last node. So how do we do that? We have to first declare the temp as such. After declaring it, we want to let it point to where head was pointed to first. Remember that everywhere we are using head, it should be asterisk head, because this is because we carried it over into a function. Okay, so asterisk head. Now temp is pointing to what head was pointing to. That means temp is pointing to the first member of the list. So we can write a while loop to check if temp next. Don't forget this, because when we get to the last node is when the next of it is now. So we are checking if temp next is equal to now. Okay. And if it is not equal to now, what do we do? So if it is not equal to now, we now update temp and say temp is equal to, then give it a value. What would the value be? We are updating it, so it now be equal to temp next. As simple as that. This means that by the time this loop runs, our temp is the last one. By the time this loop is done running, our temp is the last one. So we'll go ahead and now it's like just by running this, okay? Just by running this, we know what the last member of the list is, and it is called temp. So what do we do? Now that we know the last one, all that we have to do, since we want to connect a new item to it, we have to pass the right connection, the right one here, to do the right connection, new node next. Okay, so that's the first thing that we need to do. Points next of new node to now, because new node is now going to be the last one. Then after doing that, we'll now point last node, which is temp. Now temp next should be pointed to new node. Simple like that. So let's write the code in here. This will be, this point next of new node. So new node next is equal to now. As simple as that. Then we set our temp currently, because of this loop, our temp is now the last one. So all that we have to do is say temp next. Okay, instead of, originally it was now, but instead of now, we are now pointing it to the new node that we have created, like this. So this should work perfectly. And if everything works, let's print I successfully added a new node to the end of this list. Okay, so hopefully everything here is going to work perfectly. Let's look at Please, when you are doing it on your own or writing actual programs, don't forget the checks. You always have to do those checks. But now we are just focusing on the meat of it. So let's go to main.c. Let me comment out this, or let me copy this. If I copy everything, then add it here. What we are doing now is, let's comment it out. And what we are doing now is insert end. Okay. So initially we learned how to insert 78 to the front of the list. The actual list is 67, 47, 35. And we were able to insert 78 in front of it. Now we want to insert the 78 at the last part. Okay. So let's run it. Hopefully it should give us the kind of result we are looking for. So recompile this. Oh, implicit declaration. Come on, we haven't added the prototype. Okay. Where is structs? Let's see. Struct, okay. All right. Now let's run this. Good. Run this. And as you can see, 78 is now at the end of the list. So hope you get it. Initially, we ran it using the beginning, and we put 78 at the beginning. But this is the actual list itself, 78, starting from 67 and ending at 35. So here we've been able to put it here. The next one, we want to put it after position 2. Let's put the new list after position 2. Okay, after position 2, how do we do that? So we create another one and call it insert at position. So call this insert underscore pos.c. Okay, so we're inserting at a given position. Let me copy this. So at the given position, it's going to be a bit similar to at the end. Okay, except that you need to explicitly tell us what position. So the prototype will contain another integer value that we are looking at, say position, call it position. Okay, then what we are going to do is we are going to traverse. So in fact, we are going to maintain every other thing, but when we are traversing, we don't want to get to the end. This was to traverse to the last node, but now traverse list with a temporary node to get to the target node. Okay, we want to get to the target node. So we could actually call this target instead of temp. Okay, but let's maintain temp so that we maintain a consistency within the code. We know that our target is position 2. So that is all that we are going to do. Position 2. Once we know exactly where you have to go to, let's just get rid of this and use a for loop. For loop, but we have to we have to declare an integer called I, so that we'll use the I for the looping. And we say for I is equal to 1. We initialize it to 1. For I is equal to 1, what we have to do, we want to check if I is less than our position that we're given. Okay, and if it is less than, do everything you are going to do. After you are done, increase I by 1. Okay, so this is us trying to traverse to the specific location. So before we enter this loop, we have assigned temp to what? Head, where head was pointing to. That means temp is currently pointing at the first item in the list. When we go in there, we want to update it. So I've explained all of these things. We now want to update temp and assign it to what temp next was originally pointing to. Okay, so by the time we are out of this list, temp is the specific node that we are looking for, or that is the target node. So if we come out here, now we know our target node. So if we know our target node, that is the right connection the right side connection is for us to point next of new node to what's the next of target node was pointing to. You get it? So the target node originally at position 2 was pointing to node C, or the third node. Now that we are bringing in a new node, we want to connect. The new node should have its next pointing to node C. That's what we are doing here. So we just go and say temp next, like this. Then our temp, which we already have, the temp next, which was previously pointing to the node C in this case, we are now going to redirect it to point to the new node. So this is exactly what we are going to do here. So the only thing that actually changed in here is the type of loop that we are using, like what we are checking, the condition we are checking in the loop. Then also reassigning this, instead of now reassigning it to what the target node was actually pointing to. So hopefully I successfully added a new node to, okay, let's say a new node after node, then let's pass the value. So if it is 2 after node 2 of this list. Okay, so hopefully when we run this, we should get our 78, which we are going to call, should be inserted after when we get it. Let me start, okay, declare it here, insert end. Okay, so when we go to main.c, let's copy this. Instead of inserting at the, this was supposed to be end. So here, instead of inserting at a given position, at the end, we are going to insert at a given position. Okay, so at or after, let's say after a given position. Remember that this, I'm saying after, because you could be asked to insert it before a given position, and that will should trigger something. You should think about how to implement this. But now we are looking at inserting it after position 2. So we'll pass position 2 here. So remember that our list is this: 67, 47, 35. Position 2 is 47. So now we want to put 78 after 47. That's what we are interested in doing now. This cannot be called, and this is pause. Okay, then let's comment this out. So our focus is now on this. Hopefully it should work when we run it, and put our 78 after 47 rather. Let's run this. Oh no, implicit declaration.
The function name in the header file, you didn't change it to pause.
Oh, I see. Okay, so it means that here I didn't change it because I copied it from here. Okay, thank you. Then here too. Oh, no, some IDs, when you are using it, you can't declare the same function twice. They would have flagged it for you. Okay, let this work. There's still a problem. Oh, I didn't pass the value. Hey. The way, because of the time, like, I'm in so much hurry. We are going to print something, and I want it printed here, but I didn't give the value, so it is called pause. Okay, now we've corrected everything. Good, so let's do this. Great, so you see where our 78 is now. We've managed to put it after position 2. If I go in here to main and I change it to position 3. Change it to position 3. Then we can still run this, and it should put it after position 3 used to be. Remember, like once we are compiling the code again, we are resetting our list. Position 3 used to be 35 because the actual list is 67, 47, 35. So it's going to put it after 35. That means that it is now becoming the last one itself. So let's run this. Good. So it puts it here. We can also decide to go with position 1. Okay, position 1. But that means because of how we wrote our code, we can't use it for position 0. Okay, because we initialize from 1. Or I'm tempted to go and try. Anyway, but I hope this makes sense. Once we put it at position 1 after position 1, so this is after position 1. Okay, so that is it for the insertion. In fact, we have spent 2 hours here already, so I wouldn't want to go and tackle the deletion part. Hopefully, during the break, I may take some time to do short videos and explain some of these concepts, try some of them out, or maybe write articles on them and publish them. So hopefully you get to see it. Any questions on what we've done? So basically, we've looked at insertion, how we insert at the beginning, at the end, and at any given position. Okay. Any questions? Any questions? No questions? Then I'm going to push this code to GitHub so that you can get access to it. I think I made some changes earlier. Let's see, get status. There are a lot of things that hasn't gone, but let me get pull first. Okay, good. Then get add everything. Get commit. Let's commit this. Added new files, or let's say add new files. Then get push. Okay, so we are done for today. Hopefully I'll cover the deletion some other time. I don't think we'll call for a POD to cover that because we have other things to look at, especially the project at hand. But once we are done with all the projects and we have the free time to ourselves, I'll try to cover that. Maybe after that time, we'll see what to do. So thank you for staying through 2 hours of this lecture. And I'll see you some other time. Thank you. Bye-bye.
Thank you, doctor.
Thanks, Doc. Thanks a lot.
Welcome.